All right, so let's have a look at this set. This is a very simple one, but the last two questions of this set are quite good. So let's read out the information first. So we are given information about the number of male and female professors in each of the 4 universities, A, B, C, and D, as a percentage of the total number of professors in that university. So basically, we have been given 4 universities, A, B, C, and D, and every university has some male professors and some female professors. All right, so we have been given the percentage here. Now, the number of female professors in the universities A, B, C, and D is P, Q, R, and S respectively. So this is the value of P, Q, R, and S will tell us the number of female professors. And we have been given a bar graph which is providing some information about P, Q, R, S. So basically, we have been given 4 equations, and if we solve them, we'll get to know the value of P, Q, R, and S. Right. So the first equation, it is P plus Q plus R is equal to 4600. Q plus R plus S is equal to 6100. Q minus R is equal to 500, and P plus S is equal to 3300. So these are the 4 equations we have. Solving them, we'll be able to find the value of PQRS, and that will be the number of female professors. Now, once we know the number of female professors, we can calculate the number of male professors using this particular thing. So since we know the percentage, or we can say we know the ratio of male and female, we'll be able to calculate the number of males as well. Now, how to solve these equations? It's very simple. So P plus Q plus R is given, Q plus R plus S is given. If we just subtract equation 2 from 1, we'll get a value of S minus P, or P minus S. And we have one equation in form of P plus S. Since we have to, in order to solve any equation, we need to find convert it in the form of 2 unknowns and 2 equations, and it becomes very easy. So what we'll do 2 minus 1. So solving equation 2 minus 1 will give us, I'll write it here, S minus P is equal to 1500, and equation 4 is S plus P is equal to 3300. Now adding both the equations, 2S is equal to 4800. That means S becomes 2400 and P will become 900. Now putting the value of S in this equation, so it will become Q plus R is basically 6100 minus 2400. So it will be 3700. And Q minus R is given 500. So solving both of them, 2Q will be 4200 and Q will become 2100, and R will become 1600. So just we'll write it down. P is 900, Q is 2100, R is 1600, and S is 2400. Now we can see the ratio of male and female in university A is 9:1. So if this is 1, the 9 will be 9 times of this, that is 8100. Now here it's 7:3. So this is 3. So 1 will become, 7x and 3x. We can solve it very easily. So if the value of 3x is 2100, so x becomes 700 and 7x will become 4900. Here it is 8:2 or 4:1. 1 is 1600, so 4 will become 4 times of 1600, that is 6400. Now here it is 3:2. So 2x is 2400, so x will be 1200 and 3x will be 3600. So this will be the number of male and female professors across all the 4 universities. Now let's solve the questions. What is the number of female professors in University C? So answer is 1600. The absolute difference between number of male professors in University A, that is 8100, and number of female in D, minus 2400. Solving this, we can find out the answer is 5700. Now, what is the ratio of the total number of professors in University D to the number of male professors in University C? So the total number of professors in University D is 6000, and male in C is 6400. So 6000 by 6400, cancel out the zeros. So it will be 15 times by 4 and 16 times 4. So answer will be 15:16. So these were quite easy questions. Now considering the difficult part of it, we have some additional information now. So the additional information says 2000 professors are transferred to universities A, B, C, and D in the ratio 4:3:2:1. Right? Okay. So we'll have this table. 2,000 professors are transferred in ratio 4:3:2:1. That means in university A, how many will go? So we can solve it very easily. 4x plus 3x plus 2x plus x equals to 2,000. So x will become 200. So in university A, 800 people will go, 600 here, 400 here, and 200 people will go here. All right. Okay. Now we don't know the gender of these professors, and we cannot assume by ourselves that they will also go in this ratio. All right, that is the catch of the question. Now let's have a look at the information. What the question? Now, in which of the mentioned universities the number of male professors as a percent of the total number of professors in that university is maximum? Okay. The question being asked is, after this transfer, which professor will have the maximum number of male professors as a percentage of the total number of professors in that university? Okay. Now, since we don't know the gender of these particular professors, we cannot, prima facie, we cannot find out the answer. So the answer cannot be determined, but we can do one thing. We can just cross check the worst case scenario. So the worst case scenario, it says that if at all, since before the transfer, the number of male professors were maximum in university A, 90% of the total, right? So if at all the professors who entered university A are females, and in all the other universities, the number of professors which entered, they become males, they are males. And even after that, the number of male professors, the percentage of male professors in A is maximum. Then in any case, the number of professors, male professors in A will be maximum in A, right? Because we are just trying to check the worst case scenario, the threshold. So if we add 800 as females here, so the ratio of male is to female will become 81:17. 8100 by 900 plus 800 is 1700. So I'm writing it 81:17 in case of A. In case of B, if we add all these to males, because we are trying to increase the number of males in every other university and decrease the number of males in university A. And we'll check if after the process A has maximum number of males or not. If it is true, then A will be the answer. If it is not true, then we cannot determine the answer because it can be anyways. Now for B, 4900 plus 600, that is 5500, and upon 2100, that is the ratio of male is to female. So if you calculate a male to female ratio and you calculate the percentage of male is to total, both ways it will give the same thing. So we just need to know which university has the maximum ratio of males. So for C, it will be 64 plus 4, 6800 upon 1600, and for D, it will be 3800 upon 2400. Now, here the 17 and 81, so it will come somewhere around 4 point something close to 5, because had it been 85, it would have been 5:1. Now, this is not even 3, it's 2 point something, so we'll eliminate it. Now, this is not even 2, we'll also eliminate it. Now, again, this is 4:1, again 4 point something is to 1, but this is very close to 16 for the 64. So this 4 point something will be close to 4, not 5. So we can see that A has the best ratio of male is to female even after this worst case scenario. So in any case, the answer will turn out to be A. Now the next question, if the total number of female professors that have been transferred is equal to the number of male professors in university A after the transfer. All right, then the total number of male professors that have been transferred cannot be less than. So, okay. So out of this 2000, some males were transferred and some females were transferred, right? The question says, if the total number of female professors that have been transferred, this is equal to the number of female professors in university A after the transfer. So before the transfer, university A had 900 female professors, and let's say X professors were transferred. Out of these 200, I mean, A had 800 transfer. Out of this 800, X were females. All right, who got transferred to University A. Okay. Okay. So after the transfer, then the total number of male professors that have been transferred cannot be less than. We have to minimize the number of male professors being transferred here. So in order to minimize the number of male professors being transferred here, we have to maximize the number of female professors who were transferred. And in order to maximize the number of female professors being transferred, we have to maximum the value of X. Why? Because out of the 800 professors transferred to University A, if all the 800 are females, that will maximize this value. This X is the number of female transfers. So that will maximize this value. And once we have maximum number of female transfers, the male transfer will automatically be minimum. So putting X equals to 800, so 900 plus 800 will give us 1700. So out of 2000, maximum female transfer can be 1700. And in this case, the number of male transfers will be 300.